Recently, something incredible happened. Not with a bang or a flash, but with a whisper from the cosmos. Deep beneath the Antarctic ice, an invisible messenger arrived from the farthest reaches of the universe. It didn't make a sound, but to particle physicists, it roared. It was a neutrino, a particle so ghostly, so elusive that it rarely leaves a trace. But this one was different. It was the most energetic neutrino ever recorded in human history. Before we dive into why scientists are going wild over this discovery, let's first ask, what is a neutrino anyway? Neutrinos are often called ghost particles, not just because of their mysterious behavior, but because they're practically invisible. Every second, trillions of neutrinos pass through your body. Yes, right now. But you don't feel a thing. They don't knock atoms around. They don't bounce off your bones. They simply drift through like phantoms. Why? Because neutrinos are neutral, almost massless, and barely interact with matter. It's like trying to catch smoke with a fork. But neutrinos aren't just floating out in space. They're everywhere, even in your snack. Take a banana, for instance. Bananas contain potassium-40, a slightly radioactive isotope. When potassium-40 decays, it releases, neutrinos. So technically, every bite of banana sends a tiny burst of ghost particles flying through your kitchen. These are low-energy neutrinos, harmless. But they show just how common and fundamental these particles are. Now, back to our record-breaking neutrino. This one wasn't from a banana. It wasn't from a nuclear reactor. It came from the deep universe, probably from a supermassive black hole, a collapsing star, or something even stranger. And it was caught by the IceCube Neutrino Observatory, a colossal detector buried beneath the ice at the South Pole. Think of it as a telescope made of frozen light sensors, listening for ghost particles in a cube of pure Antarctic ice. A 1 kilometer deep frozen net, waiting for the rarest cosmic fish. So how does it work? When a neutrino interacts with the ice, which is incredibly rare, it creates a particle that moves faster than light does in ice. That's right, faster than light in that specific medium. And just like a sonic boom, it leaves behind a flash, a faint, eerie blue glow called Cherenkov radiation. That glow is what the IceCube, and then they saw it. A neutrino carrying over 10 peta-electronvolts of energy. That's a 10 followed by 15 zeros. To compare, the Large Hadron Collider, the most powerful particle accelerator on Earth, maxes out at a few peta-electronvolts. This neutrino, thousands of times more energetic. It's like throwing a baseball with the energy of a speeding train. This wasn't just a particle. It was a cosmic bullet, fired from somewhere beyond comprehension. Where did it come from? That's the mystery. Neutrinos can travel billions of light years without getting absorbed or deflected. Unlike photons, which scatter and fade, neutrinos keep their course. That makes them perfect messengers, postcards from the edge of the universe. Scientists are now scanning sky maps, cross-checking with telescopes, gamma-ray observatories, and gravitational wave detectors. They're hoping to pinpoint the origin. And here's the wild part. This neutrino might not just teach us about the universe. It might help us discover new physics. You see, the standard model, our best theory of particles, is powerful but incomplete. It doesn't explain dark matter, or why neutrinos have mass, or what happened in the first instant after the Big Bang. High-energy neutrinos like this one might be evidence of physics beyond our current models, like cracks in the wall that could lead us to a whole new room of understanding. To push this further, scientists are building next-generation detectors. IceCube Gen 2, for instance, will be bigger and more sensitive. Other projects like KM3 in the Mediterranean and Baikal GVD in Russia are joining the hunt. Together, they'll form a global neutrino network, a kind of stethoscope pressed to the chest of the cosmos. Each detection will be a heartbeat, each neutrino a cosmic whisper. We are now entering the age of multi-messenger astronomy. It's not just about what we see with light, it's about what we feel with gravitational waves and what we hear through neutrinos. Imagine a single cosmic event, like a star exploding, being detected by light from a telescope. Gravitational waves shaking space-time. A high-energy neutrino flying through Earth. Together, they form a complete symphony of data, a story told in 3 dimensions. And with each one, we get closer to understanding our place in the universe. This neutrino isn't just a particle, it's a question, a challenge, a signal that says there's more out here, come find me. And that's why physicists are going wild. Not just because it's rare, but because it means the universe is still talking to us, whispering secrets, daring us to listen. So next time you look up at the night sky, remember, the universe isn't silent. It's singing, quietly, in particles and waves. And we've only just begun to hear the tune. This is KnowledgeLab. Stay curious and keep exploring.